In this video, we're going to talk about different types of numbers. If you have to memorize the different types of numbers for a class, then this is a great place to start. If not, then we're going to get on the same page by just quickly reviewing these different types of numbers. So we start with the natural numbers, which are sometimes called the counting numbers, because we start at 1 and we just count up from there. 1, 2, 3, 4, 5, 6, so on and so on until we get to 100, a million, a trillion, and it just keeps going. If we want to add in 0, we can do that, and sometimes we write that little subscript of a 0. Sometimes we call these the whole numbers, the natural numbers with 0. That's not too important. Now, the integers have all the natural numbers, they have 0, and they have these negative numbers. So an example of an integer is something like -7. Now, -7 is an integer, but it's not a natural number, because there's no negatives in the natural numbers. On the other hand, something like 20 is both a natural number and an integer. We can clearly count up to 20 in the natural numbers, and if you look at the integers include all the natural numbers, 1, 2, 3, 4, 5, and so on. Now, what's an example of a number that's not an integer? Well, how about something like a fraction? Now, when we move to if we want to include all the fractions, then we move to the rational numbers. So, for instance, 1/2 is a rational number, but it's not an integer. Now, 1/2 is a rational number because if you look, 1 is an integer in the top and 2 is an integer in the bottom. So when we make a fraction with integers, that's a rational number. Now, can you think of any examples of a number that is both a rational number and an integer? Well, 5 is both. Why? Think about it. 5 is definitely an integer and a natural number for that matter, but it's also a fraction because 5 is the same thing as 5 over 1. Now, 5 is an integer and 1 is an integer, so we can write 5 as a fraction of integers. So 5 is a rational number and an integer. In fact, all the integers are rational numbers. Now, what about things that are not rational numbers? Well, the square root of 2 is not a rational number, but it is something called a real number. So real numbers are all the rational numbers, all the fractions, and there are these mysterious things like the square root of 2 and the square root of 3, and numbers that we call irrational. So, for example, 5/2 is a fraction, so it's both a real number and a rational number. But the square root of 2 is only a real number. We'll talk more about the real numbers at the end of the video, but they're really, really, really important. They're the numbers we'll be using most often in this course. Finally, we get to the complex numbers, which are just real numbers with imaginary numbers, things of the form a plus bi, where a and b are real and I is the imaginary number square root of -1. Now, if the complex numbers right now seem mysterious and weird to you, don't worry about it. We'll talk about it later. But let's revisit the real number line, or the real numbers. So this is the real number line, and it's just a continuous line of numbers. You can see we have all the integers, 1, 2, 3, and so on. We also have everything in between. So, for example, right where that green dot is, that's perhaps the square root of 2, because the square root of 2 is approximately 1.414, and it keeps going on forever. So it's just a little less than 1.5. Now, the interesting thing about this is that if we were to draw a number line with only rational numbers, so only fractions, well, we already talked about the fact that the square root of 2 is not a rational number. It's not a fraction. So if we drew a number line with only fractions, there would be holes in it. There would be a hole where the square root of 2 goes. So the real number line is really special. It has this property that every number is there. There's no holes or jumps or gaps. And we'll use the real number line in that sense, that basically when we can think of it as all the numbers on that line, the whole line is continuous and filled with numbers. Okay, see you in the next video.